Okay, continuing into point 1 in the learner guide, we have a couple of terms that are being defined. First one in the pencil problem says true or false. The parts of an algebraic expression that are separated by addition are called the terms of the expression, and that is true. That's the definition of a term. If you'll look at the one that's already solved, it says true or false, the numerical part of a term is called the variable. And we know that that's false because the numerical part of a term is actually called the coefficient. Okay, all right, let's look at number 4a. We're going to simplify this expression. Notice that none of these have equal signs. So we're still dealing with just expressions, and the result when we simplify an expression, like in the solved problem, notice that we still have variables and numbers. We don't end up at the end with x equals a solution. So we're just simplifying the expression. So as I do that, I'm going to first look at use the order of operations. However, in the parentheses, there's nothing to work out inside of those parentheses. That's already simplified. So then we're going to look for any exponents. We have none. Next is multiplication, and I do have the distributive property multiplying 5 times 3x, which would be 15x, plus 5 times 4, which would be 20, minus 4. Then we'll add and subtract from the left to the right the like terms. 15x plus 20 minus 4, which would be a positive 16. And that's your simplified algebraic expression. Okay, we're going to do the same thing with 4b. So as we look at parentheses, again, there's nothing for us to work within those parentheses. So we move on to exponents, which there are none. Then again to multiplication. So as we multiply, and notice this negative in front of the parentheses, we treat like it's a -1. I'm even going to draw that in there. Okay, so 5 times 3y would be 15y. Now distribute the 5 times the -2, which would be -10. And then we'll multiply again, distributing the -1 to both of those parentheses. So -1 times 7y would be a -7y. And then -1 times a +2 would be -2. Add from the left to the right, add or subtract. And we'll look at only the like terms here. We can actually regroup them. There are a couple of properties that talk about like our commutative property and associative property that allows me to rearrange these. So if I wanted to look at them and group them in order, I could rearrange this to be 15y minus 7y minus 10 minus 2, and then we could add the like terms together. 15y minus 7y is 8y, and -10 minus 2 would be a -12. Okay, and then one other expression here. Make sure that you don't jump ahead and look at that 7 minus 4. That would be jumping outside of our order of operations. So what we want to do is go to the innermost parentheses first, which there's nothing to work out in those parentheses. So then we look at the second set of parentheses or brackets, and we want to use our order of operations to work this. So I don't have any exponents. The next thing I would do would be multiplication. So I'm going to distribute that negative, which is like a -1, to both of those terms. 7 minus 4 times 3, and then I have a -1 times 4y is -4y. -1 times -5 is a +5. Then we will, still working in the parentheses, add the like terms. So we have 7 minus 4 times 3 plus 5 is 8 minus 4y. Okay, we're finished with that set of grouping symbols. So now we'll look back at the whole expression. We want to do any exponents, which we don't have, but we do have multiplication because we have now another distributive property. So 7 minus 4 times 8 would be a -32, and -4 times a -4y would be a +16y. And now we're left with just addition and subtraction from the left to the right. So 7 minus 32 is negative 25 plus the 16y. Now you can write your answer like this, or just using the commutative property, I could have the 16y first. It's a positive 16y and a negative 25. As long as you rearrange them with the signs included, you could rearrange that statement. There's no reason to, though. This would be counted also as correct. Okay, I'm going to add one more problem to what we have here. This is actually coming from your textbook. I'm just going to add it right here. If you were to look in the text on page 109, number 33, 2x plus 3y over x plus 1, where x is negative 2 and y is 4. So just to get an example with a fraction in here, let's look at this one. So we would have substitute negative 2 in for x, so 2 times negative 2 plus 3 times y is 4 over negative 2 plus 1. And then using our order of operations, do the numerator separate from the denominator. The first thing that comes up in our order of operations is multiplication. So 2 times negative 2 would be negative 4 plus 3 times 4 is 12. The only thing left to do in the denominator is to add. So negative 2 plus 1 is a negative 1. Go back to the numerator. Negative 4 plus 12 is 8. 8 divided by negative 1 would be negative 8.